Good morning, one and all. Welcome back to the video lecture series for signals and systems. This is Dr. P SREENIVASULU. Today we are going to obtain Laplace transform of some standard signals. Now, what are the standard signals? We know the standard signals are impulse signal, unit step signal, ramp signal, and cause signal, and sine signal. So these are frequently we are going to use as an inputs for system or whatever it is we are going to be analyzed from time domain to S domain. Now first of all, if you see here, find out the Laplace transform of unit step signal. Now all of you know unit step is a positive sided sequence or positive sided signal. Now u of t is equal to 1 for time t greater than or equal to 0. U of t is equal to 1 for time t greater than or equal to 0, and it is 0 otherwise. So the limits are here. U of t is equal to 1 means it is like a step, whatever your staircase, up to that time t equal to 0, it is at one level, it means 0, amplitude is 0 from minus infinity to time t equal to 0, and from time t equal to 0 to infinity, that amplitude is 1. So from minus infinity to 0, it is 0. From 0 to infinity, its amplitude is 1. So the unit step signal means it is going to be, the limits are going to be considered 0 to 1. Okay. Now, if you write a Laplace transform of u of t, it is equal to general formula from minus infinity to plus infinity, u of t into e power minus st into dt. Now, what is this u of t? U of t is a 1 for time t greater than or equal to 0. So, whenever it is a time t greater than or equal to 0, that limits are from 0 to infinity. So, you write from 0 to infinity. Within these limits, the u of t is 1 and it is a e power minus st into dt. And you can integrate this term e power minus st. So, integration of e power minus st, you know, e power minus ct dt integration e power minus ct divided by minus c. Similar fashion, we are doing the integration with respect to dt. So, e power minus st divided by minus s. Now, the question is it exist for all values of s? Is it exist for all values of s? That is the question. Now, after substituting these limits, instead of t, first one is e power minus s into infinity minus e power minus s into 0. We write that limits after upper limit and lower limit, e power minus s into infinity minus e power minus s into 0. This e power minus s into 0, there is no any confusion because e power minus 0, it is a 1. In the upper limit, e power minus s into t, if you see here, there is a e power minus infinity, and along with this infinity, there is a s. Suppose s is less than 0. Suppose s is less than 0. Already there is a minus. Whenever this s is less than 0 means it is a negative. Minus into minus plus, it is going to be become e power infinity. Then it is not going to be exist. That's why you need to apply the condition that is an ROC. Definitely this s is greater than 0. Definitely for existence of this Laplace transform, you need to write s must be greater than 0. So it is the condition, it is nothing but ROC. So whenever s is greater than 0, then s is a positive. This e power minus infinity is 0. Now 0 minus of 1 divided by minus 1 by s. This minus minus gets cancelled. So finally we are going to get 1 by s. Now we need to write that ROC. What is the s? S is a sigma plus j omega. So sigma plus j omega is greater than 0. Sigma plus j omega is greater than 0. So after comparing this real part and imaginary part, omega is a anyway 0. Only if we see this real part of s. Real part of s is greater than 0. So what is the real part of s is greater than 0? That is nothing but sigma is greater than 0. Now, where we have a pole here, these are the denominator, whatever the denominator polynomials, we need to find out the roots. And then whatever the roots we are going to get, these roots are equal to 0. Then these denominator roots are called poles. So where we have a pole now, at s is equal to 0. Now, if we draw here, there is not drawn ROC, but we need to draw definitely ROC. Now, you draw the imaginary axis. On x-axis, you take real part of s. On y-axis, you take imaginary part of s. And then you locate a pole at s is equal to 0. And then what is your ROC? This real part of s is greater than 0. Or sigma is greater than 0. Here omega equal to 0. Now, the entire right-sided region, you need to shade that one. It is going to be ROC here. So it is anyway u of t is a right-sided signal. So we are going to get the ROC is also right side. So it is about a Laplace transform of u of t is 1 by s. Next, you see another standard signal. What is this one? Find out the Laplace transform of ramp signal. You know about ramp. Ramp signal means if we see in a mathematical form, r of t is equal to t for time t greater than or equal to 0. And it is 0 otherwise. R of t is equal to t for time t greater than or equal to 0 and it is 0 otherwise. Now, time t greater than or equal to 0 means what? When our time is goes on increases, that corresponding amplitude is also goes on increases. So if you see, it is like an unstable signal only, generally, because at time t equal to infinity, what is the value? We are going to get it is infinity. Is it absolutely integrable? No. Suppose if you apply for this type of signals in Fourier transform, it is a difficult for analyzing this one. Now, coming for Laplace transform. So this r of t means t into u of t. Because time t greater than or equal to 0 means what? Comes under u of t is comes under. So this Laplace transform of r of t is equal to minus infinity to plus infinity into r of t into e power minus st into dt. So what is the r of t? You need to substitute that one, t into u of t. So what is the u of t? U of t is 1 in between 0 to infinity. So you replace that limits from minus infinity to plus infinity. In this, has given only 0 to infinity directly, but you need to write every time the formula is from minus infinity to plus infinity. Now, this t into e power minus st into dt. Now, the u of t is from 0 to infinity. You can integrate this one by integration by parts formula. Is simply integration by parts formula. Suppose integration of uv dv, it is equal to u into integral v dv minus integration u dash and again integration v dv, and then we can apply whole integration, general in the uv dv formula. Now here you can assume a t and v is e power minus st. So u as it is we are going to keep here. And the second term, if we integrate, e power minus st integration is e power minus st by minus. Yes, because we are doing integration with respect to dt minus integration. Derivative of t with respect to time, it is a 1. And again, whatever the integration in the first part, that is going to be right here. And then the second part also, you can apply second integration. This e power minus st integration same. And again, we are going to get one more minus s. So minus into minus plus. So e power minus st by s square we are going to get. And then you substitute that limits. And then you substitute these limits. So this is there is a minus e power minus st. I think it is a print mistake here because minus into minus plus. So it is a s square only. So if you substitute these limits, we see here t upper limit is infinity into e power minus infinity into t by minus s minus lower limit is 0. So that factor anyway there is a t is there. So that lower limit part is going to become 0. Coming for upper limit, this t is infinity. If you as it is, if you leave it, it is not going to be exist. Now you need to concentrate on exponential term. In this exponential term, e power minus infinity is there. E power minus infinity into s is there. Suppose this s is greater than 0. Suppose this s is greater than 0. This e power minus infinity, e power plus infinity is also infinity. So it is not going to be exist. So that's why this s, we need to assume s is less than 0. S is less than 0. S value is going to be get negative. Minus into minus plus. This is going to be e power infinity. It is not going to be exist. So that's why there is a condition here. Whenever s is greater than 0. Whenever in this book he has not concentrated all these things. But you need to remember, for existence of this Laplace transform, there must be consider this ROC. So the ROC is here, s must be greater than 0. So whenever s must be greater than 0, that t into e power minus st term is going to be 0. So first part is going to be 0. Coming for second part, e power minus st, again you see e power minus s into infinity. Here also same problem. Suppose if we take s is less than 0, it is a 0, minus, negative, minus into, already minus is there. This s is also negative, minus into minus plus, e power infinity is not going to be exist. So that's why you need to assume here s must be greater than 0. So then only this term is also 0. Next term, there minus into minus plus we are going to get. This e power minus 0, it is a 1. So 1 by s square. And the corresponding ROC, you need to concentrate. The corresponding ROC is, what is the corresponding ROC? The real part of s is greater than 0. So the real part of s is greater than 0 means s is greater than 0. What is the s? Sigma plus j omega. So there is no imaginary part. So real part of s is greater than 0. Again, you take imaginary axis here, s plane. And x-axis you take real part, that is sigma. And y-axis you take imaginary part, j omega. And here you observe here, there is a 2 poles at origin. There is a 2 poles. So you need to locate multiple poles at s is equal to 0. You can cross, double cross. So that means indication that there is a 2 poles at origin. So whenever there is a 2 poles, and then you see the corresponding ROC is real part of s is greater than 0. So real part of s is greater than 0 means what? It is going to be get right-sided signal. So whenever it is a right-sided signal, the ROC is going to be get entirely right-sided ROC. It is about Laplace transform of standard signals. We will see in the next class remaining signals.